All right, in this video, we're going to be going over how to analyze trusses and frames. So let's first go over how to analyze trusses. There are different methods that you can use to analyze a truss. So there's your method of sections, method of joints, and then there's like a modified method of joints. And this is kind of your shortcut or quick way to analyze an entire truss. So this is what we're going to be covering in this video, is how to do it quickly, because on the FE exam you don't have a lot of time to analyze a truss. But if you are interested, you can look up the details of method of sections and method of joints in our statics videos, which we just have online for free or on YouTube. So let's go ahead and look at an example of a truss. If we've got this guy right here, draw in the nodes, and we'll say it's pinned on this end, there's a roller on this end, we've got a vertical point load of 5 kips coming in here and a horizontal point load of 5 kips acting there, and put our dimensions, boom, boom, boom. We'll just say these are 2 feet each. And we'll just say the height of the truss is 4 feet. All right, and then we'll go ahead and label these A, B, C, D, E. Okay, so the first thing you have to do in analyzing a truss is to find the reactions. And so you just treat this as a whole rigid body to find your reactions. So just treat it as a simply supported beam. And so we're going to take a moment about A. So we'd have our vertical 5 kips multiplied by a horizontal 2 feet positive plus 5 kips horizontal multiplied by 4 feet vertical equals minus our CY reaction vertical times our horizontal distance of 8 feet equals 0. If you solve for CY, you get 3.75 kips vertical. Then you can take a sum of forces, X equals 0, and you'll get that negative AX plus 5 equals 0, so AX equals 5 kips that way. And then sum of forces, Y equals 0. You'll get AY minus 5 kips plus 3.75 kips equals 0. And you'll get the AY equals 1.25 kips up. All right, so once you have that, then you can just redraw your truss as big as you can. All right, And then we are just going to apply all of our external forces to this large truss that we've drawn here. So we had AY as 1.25 kips and AX as 5 kips. And then we had 5 kips coming down here. And then we had 5 kips here. And we had our reaction at C as 3.75 kips. All right, let's go ahead and label our nodes. So A, B, C, D, and E. All right, so how this is going to work is you're going to just add up all the forces at each node to equal 0. So each joint, just as you would in the method of joints. So we know that we've got 1.25 kips acting up at A. So we know to balance that out, we need a vertical down of 1.25 kips. Then we can use our proportions of the slope of this member right there to find our horizontal component of that. So from this node to this node, there's a horizontal distance of 2 feet. And from this node to this node, there is a vertical distance of 4 feet. And so we can proportion that out to being, we need to find our horizontal, and we know our vertical is 1.25 kips, which we pull from right there. All right, so if we run the math on that and we solve it, then we get that this will be 0.625 here. So x equals 0.625, which was our horizontal component, so we place it here for our horizontal component. Then you can just use the Pythagorean theorem to solve for the force in the member. So you're going to do the square root of 0.625 squared plus 1.25 squared, which ends up being 1.40 kips. All right, now, so we have this arrow coming down here, and so we know that this arrow up here has to also be pointing away. So your arrows are either both going to point in towards each other, or they're both going to point away from each other. This one had to be down because this here is up. So this is down, so this one also has to point away from it. Now, because of that, we know that this member here, because the arrows are pointing away from each other, is going to be in compression. All right, so then we can continue to look at A, and we've got 5 kips going to the left and 0.625 kips going to the left. So in order to balance that out, make it an equilibrium, we've got to have some horizontal force acting in the right direction. So we know 5 plus 0.625 is 5.625 kips. And so now our forces at A all add up to 0, so we're good there. Now you would continue to do that all the way around your truss until you've completed the whole thing. Now, on the FE exam, they'll probably just ask for one member in particular, like say BE. So you would probably want to start at A, and then you would move up to here, and you could find BE. But if they asked for, say, CD, you wouldn't want to start at A because then you'd have to work all the way around. But you could start at C, and you would be able to find that in like one step. So just be aware that there are things you can do to make the problem go quicker. All right. Now, if this quick way doesn't make sense to you, go ahead and just use the method of sections or the method of joints. All right, they're gonna get you the same answer. This is all about what is quickest and most efficient for you. I feel like this way is the quickest and most efficient, but if you don't understand it, then that's not gonna be the quickest and most efficient for you. So again, you're just looking at each node individually and trying to make sure all the forces add up to equal 0, as if you were using your method of joints. All right. So let's go ahead and let you try one of these on your own. Let's say you've got a very similar to what we just did. All right, so you've got a pin here and a roller here, and it's gonna be 10 feet tall with boom, 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 3 feet, 6 feet, 6 feet, 3 feet. And you're gonna have a 10 kip load. Acting down at B. All right, and this one is gonna be find the forces in all members. Identify if member is in tension or compression. All right. So go ahead and pause the video, work that out, and then you can check your answer with the PDF. This will be number 1 in that PDF. All right, let's talk about frames now. All right, so the biggest thing that you need to know about frames are, let's just say we've got something that looks like this. So these corners here at 90 degrees are fixed at 90 degrees. They can't be deformed. So you can't end up with a deflected shape. Let's say if you pushed on here, you wouldn't have something like that, because this here has to stay 90 degrees, right? This here has to stay 90 degrees, all right? So with that said, let's just go ahead and look at an example similar to this. All right. Got our 90 degrees, 90 degrees. Again, they stay 90 degrees. Pin, roller, A, B, and we've got 5 kips acting right there. We'll say this is 5 feet tall here and 5 feet here. And then we'll also put 5 kips acting down right there. And we're just gonna find our reactions for this frame. All right, so first things first, let's just draw a simple free body diagram. All right, so we're going to have vertical and horizontal reaction at A, vertical reaction at B, and then our external applied forces. All right, so let's go ahead and take a sum of moments about A. So we're going to get our horizontal 5 kips times our vertical 5 feet plus our vertical 5 kips times our horizontal 5 feet minus our reaction at B times our horizontal 5 feet equals 0. You'll solve for that and you'll get By equals 10 kips up. All right, so that would be one reaction. Now if we take a sum of forces X equals 0, we're going to get minus AX plus 5 kips equals 0. So AX equals 5 kips in going in the left direction. And then finally, our sum of forces Y equals 0. We're going to get AY minus 5 kips plus BY equals 0. So AY minus 5 kips plus 10 kips equals 0. So AY is going to equal a negative 5 kips. Now, all that negative means is that we assumed our direction incorrectly. So really, AY is going to equal 5 kips down. All right. So that would be how you would find your reactions for a frame. So go ahead and try on your own. This frame here, if you've got a frame where it's fixed at the base, and you've got a rectangular distributed load acting on the top of it at 5 kips per foot. And then you've got a horizontal point load of 10 kips acting here at the bottom of that frame. Now this distance here, we're going to say is 1 foot. And then this whole distance here, we'll say is 7 feet. And then this distance here is going to be 5 feet. And you're just going to find all reactions. All right, so run through that. Check your solution with the answer. This is number 2 in that solution. And then go ahead and work out the quiz for this section.